Okay, the next step is think aloud. Okay. As I am studying, so I will write down the brute force recursive solution that we discussed. It's a direct translation of the recurrence relationship. Okay. Solution number 1. Brute force recurrence O to exponent time O and space. Oh my god. We will calculate the number of ways to climb and stairs using a native recursive approach. Note, this solution is inefficient and will exceed the time limit for lecture n. Okay. The number of ways to climb and stair using a native recursive approach. Note, this solution is inefficient and will exceed the time limit for lecture and function. So solution climb stair recursive with n number, return number. If n equal 1, return 1. If n equal 2, return 2. Return with n minus 1 plus n minus 2. Perfect. Okay, now we will try with the next solution 2. In this method, I will calculate the number of ways to climb and stair using an optimized bottom-up dynamic programming approach with constant space. Perfect. What will we do? I will function climb stair and number. First, I will handle the base cases. If n is 1 or 2, the number of ways is simplified, and this covers the CH cases and provides the starting point for our calculation That means if n smaller or equal to, we will return n. Oh, okay. I initialize two variables to check the number of ways for the two preceding steps. Let me check how to spell it. Preceding, yeah, preceding. I will start my loop from I equal 3, so those variables will represent the way 4. Step 2 and step 1 respectively. Let one step before equal to. It will represent ways with I. Last one, initialize for I equal 3, so it's ways 2. Let two steps before equal 1 represent ways I minus 2, initialize for I equal 3, so it's ways 1. Perfect. Okay, let me show it for you. It's about right here. You see? So it will be step 1 plus 1 step. Okay, next. And I will use a variable to store the weights for the current step I. Let current weights equal 0. It's a time to loop from first step up to the target step I n. For let I equal 3, I smaller or equal n, I plus plus. We have the number of ways to reach the current step I is a sum of the ways to reach the previous two steps. As per our recurrence relation, we will have current ways equal 1 step before plus 2 step before for the next iteration. The step that was 1 step before we now become 2 steps before. We are sliding our window forward 2 steps before equal 1 step before, and 1 step before equal current voice. Return 1 step before. Okay. On the step number 4, we will provide a simple example. Okay? I will tell the interviewer let's quickly test with n equal 4. What do we have? 1 step before is 2. 2 steps before is 1. I equal 3. We will have a current voice equal 2 plus 1 equal 3. And I equal 4. Current voice equal 3 plus 2 equal 5. Exit time 1 step. One step equal 3, 2 step equal 2, 1 step 5, 2 step 3. So return 5. Perfect. Okay, let me dig into this one. It's simple right here. Okay, perfect. Okay, let me try with this one. Okay, we have n here equal 4 right here. So we will have at this time we will have a 1 step into the first one. We will have a current way equal 1, 2, 3, 3, and then 1 step. 2 step will be number 2, and 1 step will be 3. So at this time we will have a 3 right here, and then 3 current way will be 3 plus 2, and we have a 5, and then we return 5 step. Okay, yes, perfect. Okay, so I think it's the first time I work with the structure, and I have a lot of job I have to work here. So I think after around 5 or 10 problems, I will familiar with the structure. I hope this will help me and give me a chance to explain everything clearly. Keep fighting. Okay, see you.